mass, maybe just one. We'll probably just do one, talk about that, and then we're going to move into something called limiting reactants. All right, so we have ammonium nitrate is going to produce N2O gas and water when it decomposes. So I've got ammonium nitrate here. I am going to produce N2O, and I'm going to produce water. Okay, balance this. I've got 2 of those. I have 3 of those. Okay, I don't have 4 of those though, so I need to put a 2 here. So I've got my 4. Then that's going to, yeah, that takes care of my oxygen too. So my oxygen's now, so I think I'm balanced. Can you guys confirm that? Okay. All right. So here we are starting out with grams. So we can't put grams in this table. We have to have this in moles. There's only moles in the holes. Okay. So I'm going to divide this by its molecular mass. So I'm going to take nitrogens. So my molecular mass here is 80. I took 2 nitrogens, 4 hydrogens, and 3 oxygens, added them together off the periodic table for their masses, and I got 80. So 25 divided by 80 is 0.3125. So that's how many moles I'm starting out with. I don't have any of this stuff made yet. So I'm going to take this up into the cloud. My cloud then, I'm going to divide this by 1. So 0.3125 is going to become my cloud. Then I'm going to come back down out of the cloud, and I'm going to multiply by the coefficients. I'm going to subtract from my reactants, and I'm going to add to my products. Okay, I won't have any of this left. I'm going to have 0.3125 here, and I'm going to have 625 here. All right. So you guys are getting comfortable doing those? Okay, and then they wanted us to determine the mass of the water produced. So I'm going to take this and I'm going to go times 18, which is the molecular mass for water. And that gives me 11.25 on my calculator, but I'm going to write down what? 11.3. Because I have 3 sig figs here in my measured amount. This is going to be 11.3 grams of water, and that's going to be my answer. Good? All right. So, are you okay with that? Did all of that make sense? Anybody need me to do this next problem, or can I skip to the new topic today? Okay. So, limiting reactant then. Generally, 1 or more reactants are in excess. So you've got extra left over. So like I was saying with cookies, if you're making cookies, you're going to measure out your flour. You're going to keep making cookies until you run out of one thing, but then you're probably going to have the other stuff left over, like the flour and the sugar and all of that stuff. Okay. So if I said, go home, here's a recipe, you're going to make cookies until you run out of one of these things. Okay. You probably still have other stuff left over. And that's what you're trying to figure out. You're trying to figure out which one of the things is going to limit you from making more stuff. And that's the thing that you run out of first. Okay. So the amount of the product depends upon the reactant that is limited. In other words, what you're going to run out of first. Okay. The limiting reactant limits the extent to which the reaction runs, and that'll determine how much you can make. Oftentimes, we abbreviate this LR because we are lazy. All right. What's left over is called the excess reactant. Okay. So I'm going to show you, here are the rules for it. You can read through those on your own time. I'm going to show you how to do this using this example. Okay. So I've got sulfur. I have 4 chlorines. And that's going to make, I can probably make this a little bigger. Maybe that'll make it easier for you to see. Is that better? Okay. That's going to make, that's a sad looking arrow, 4S2Cl2. Okay. So now we're starting out, instead of one of these being marked excess like you were doing yesterday, we have amounts for both of these. Okay. So we've got to turn both of these into grams. So I'm going to take this guy and I'm going to divide by what 8 times 32.1 is, which is 256.8. 256.8. So 200 divided by 256.8 is 0.779. And then this guy, I'm going to divide by 71, which is 2 chlorines. So 100 divided by 71 is 1.41. Now, just looking at these two numbers, you're like, oh, I've got less of this stuff. That must be my limiting reactant. But it doesn't work that way because you're going to use 4 times this for every one of these. So 4 of these for every one of these. So you've got to go back and you've got to find clouds for these. Okay, so I'm going to create a cloud here. I'm going to go take this up into the cloud. This is going to be my S8 cloud. And it's going to be 0.779 because this divided by 1 is 0.779. This guy is going to be divided by 4, 0.32352. So I got 2 clouds here. Okay. Everybody up with me at this point? Okay. Now, you're going to look at your clouds. Whichever cloud is the smallest, you keep that one and get rid of the rest. You can either cross them out, you can erase them, whatever you need to do. You're getting rid of it. You don't need it anymore. It's not going to help you. It's only going to hurt you. Okay? So you're going to get rid of that guy. And now you're going to proceed just like you did before with these problems. So this guy is going to go down. He's going to go minus 0.352. This one's going to go down. We're going to take it. We're going to multiply it by 4. This is going to be a minus 1.41. And this will be a plus 1.41. All right. So then I'm going to add these up. I'm going to subtract here. Why did I put a 0 there? I'm going to add these up. Better. Whew, losing my mind. And then I'm going to subtract here. So 7, 2, 4. This is how much excess I have left over. Okay. And they wanted to know how much mass, what the mass of this disulfur. So we're going to take this and we're going to multiply it by the molecular mass for this. 32.1 times 2 plus 1. So 135.2 times so this ends up being 190, and I need 4 sig fig, so 190.4, and that's going to be grams of S2Cl2. Are there any values up there that you don't understand where they came from? Everything making sense? where I got all the values from. These are your molecular masses off the periodic table for each one of those substances. Okay, you good? We'll try another one. Okay. Reaction between white phosphorus and oxygen. So white phosphorus is P4 plus oxygen. Tetraphosphorus. I think I've got an extra. I got an extra box here that we didn't need, so you can ignore that box. Sorry. All right. So, got to balance this. I need a 5 here. All right. So we've got 25 grams of this guy. So I need to divide him by 4 phosphoruses. So that is 30.1, or no, 31. So 4 times 31. So 124. 31 times 4. Yep, 124. Okay, so I'm going to divide this by 124. I'm going to divide this by 32. Good. So 25, 124. So for my phosphorus, I have 2. And for my oxygen, I have 1.56 and 0. I'm going to add here, subtract here. I can do this cloud in my head. All right. What's going to be my limiting reactant? The phosphorus or the oxygen? Phosphorus. This is the smaller cloud. So we're getting rid of this guy. He's going to go away. So you can erase him. You can mark through him, whatever you want to do. Okay. And now we just proceed. So 0.202 here. Uh, 1.01 here and 0.202 here. So I don't have any of this left over. This, I'm going to have 5, 5, so 0.55, 0. Here, I'm going to be making 0.202. All right, they wanted to know how much of this we're going to make. 124 plus 10 oxygen, so that's 304. So I'm going to multiply this by 304. I got 61.4 because I want 3 sig figs. P4 O10. So that is the answer to A. Now I need B. They're asking us how much oxygen are we going to have left over. So this is the amount that's left over. If they asked us how much oxygen we used, we would use this amount. But they're asking us how much we've got left over. So we're going to use the bottom amount because after the reaction, this is what remains. So I'm going to multiply that by 32. And I got 17.6. And that's going to be grams of O2. How many more do you want me to do? Are you getting the gist, or do you want me to do some more? Anybody want me to do another one? Making sense? Okay.